بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. I would like to welcome my students from grade 9 into a new online lesson, and in this lesson we will talk about the fourth lesson. This is going to be the fourth lesson in chapter 2, which is going to be about the binomial theorem. So as I told you now, this is the fourth and the last lesson in chapter 2. So before we start, it's important to know that this is one of the most important lessons in this unit. You're always expecting a question, at least, from this lesson. So it's going to be a little bit long. It might take us 2 or 3 classes to finish, but generally it's not that hard. Just needs some practice. Okay, so before we start, let's take the first point, which is an introduction. So in this introduction, we will talk about the binomial theorem. We will see what do we mean by the binomial theorem. Okay. First of all, the word binomial, the word bi means two, and nomial is usually referring to terms. So when we say binomial, we generally mean 2 terms. So the binomial theorem is a theorem that is related to expressions that are written as 2 terms. Okay. We know that this is a binomial, a plus b, right? Now, and I think all of you know how to open a plus b to the power of 2, how to expand this bracket. Now we know that a plus b to the power of 2 is equal to, you open this with what we call the smiley face, right? It's a perfect square. So a times a, which is a squared, plus a times 2 times b, which is 2ab, and then plus b times b, we get b squared. So this is how we expanded a bracket to the power of 2. Now the question is, how do we expand the same bracket, which is a plus b, to the power of 3? So generally what we do is we think of this as a 1 bracket, a plus b to the power of 2, multiplied by 1 bracket, a plus b to the power of 1. And then the first bracket, a plus b to the power of 2, is expanded as we did in the first step. So it is a squared plus 2ab plus b squared. The second bracket is to the power of 1, so it remains the same, a plus b. And then we will multiply a by all of them, by all the terms in the first bracket, and we will also multiply b by all the terms in the first bracket. So we will multiply a by a squared, we will multiply a by 2ab, and we will multiply a by b squared, and then we will do the same thing with b. We will multiply b by a squared, and b by 2ab, and then b by b squared. So let's see, what do we get? So if we do this, what do we get exactly? We will get the following. We will get a cubed plus, when we multiply a by 2ab, we get 2a squared b. Then plus a times b squared is ab squared. Then plus a squared times b is a squared b, plus 2ab times b is 2ab squared, and then plus b squared times b is b cubed. Now we can collect like terms. This is 2a squared b, and this is a squared b, so it becomes a cubed plus 3a squared b. This is ab squared, this is 2ab squared. We collect them, we get 3ab squared, and we end with b cubed, and this is going to be the answer to a plus b to the power of 3. You might have noticed that a plus b to the power of 3 takes a lot more work than a plus b to the power of 2. What if we had, what if the question was a plus b to the power of 4? Now, if it's to the power of 4, the way to expand it is to write it as a plus b to the power of 2 times a plus b to the power of 2. A plus b to the power of 2 is the trinomial that we wrote earlier, which is a squared plus 2ab plus b squared. And the other one is exactly the same. So it's a squared plus 2ab plus b squared. And then we'll have to expand all of them, multiply a squared by the whole thing, and 2ab by the whole thing, and b squared by the whole thing, and then collect like terms. If we do the whole process, we will get something like this. We will get a to the power of 4. So we will do some process here, which is multiplying and collecting like terms. We will get a to the power of 4 plus 4 a cubed b plus 6 a squared b squared plus 4 a b cubed plus b to the power of 4. And this is going to be the expansion of a plus b to the power of 4. Okay, now, what if we want to expand something like this? A plus b to the power of 20. Now, this is not going to be an easy task at all, because we're going to have to multiply 10 brackets just like these trinomials, 10, and get the expansion. Now, this is why the binomial theorem is important. The binomial theorem is a tool with which we can expand these brackets, power 2, power 3, power 4, power 5, power 20 even, no problem. We can expand any of these brackets without having to do the whole process. With the binomial theorem, we can jump directly into this step, or maybe one step into this step. So it's 2 steps. So what is the binomial theorem exactly, and how do we apply it? Let's see. So let's move on to the second slide. So the binomial theorem. Okay. The binomial theorem says the following. For any binomial a plus b to the power of n, this binomial can be expanded as follows. The answer will be sigma, where r is equal to 0 up to n of combination n and r times a to the power of n minus r times b to the power of r. And this is exactly what we call the binomial theorem. So let's investigate now how can we work out such a theorem to solve problems like the problem that we have seen earlier. So this is the binomial theorem, and this is the first formula that you need to learn. Actually, this formula is not very important for the ministry exam, I'll be honest with you. It's almost unlikely, almost impossible that they will ask you to find the full expansion of something, but it's important for your academic life. People are going into engineering, going into any field that is related to math. This is going to be important for them. So let's practice it a little bit with some examples, and then we will see what's important for us in grade 12. So let's take some examples. So here. So let's write here exercises. Expand. And what do they want us to expand? A. They want us to expand a plus b to the power of 4. And b, they want us to expand 2x minus 3y to the power of 5. Okay. So these are some expansions that we need to do using the binomial theorem. So let's attempt to solve them. Let's check the first one. So A. What we want to expand is a plus b to the power of 4. So according to the binomial theorem, this equals to the summation, where r is equal to 0 up to n, of combination nr, a to the power of n minus r, b to the power of r. What does that mean? Okay, if we write it here, it's going to be the summation r equals to 0 up to n. N in our case is 4. Then combination 4 and r, n is 4, times a to the power of 4 minus r times b to the power of r. Now you might have noticed that I have substituted n by 4 because n is the power which is here. But I have not substituted r. Why? Because in the summation, r will be different from one term to another. I'm not expecting one term to be the answer. This is all one term. But I'm not expecting the answer to be one term. I'm expecting the answer to be more than one term. So r is going to be different from one term to another. It will start at 0. And then r is like a counter. It increases by 1 every time. So r starts with 0. It will increase, it will become 1, and then it will become 2, and then it will become 3, and then it will become 4. It will stop at 4. Why do we stop at 4? Because we stop when we reach to this number, which is 4, which is taken originally from n. Let me show you how. So this is going to be the following. So it's equal to combination 4, 0. So how much is r? r is 0. Times a to the power of 4 minus 0 times b to the power of 0. Summation means addition. So now addition. And once we do the addition, it means r now would increase by 1. So now this time r will be 1 and 1, 4. A to the power of 4 minus 1 and b to the power of 1, which is r, plus the next combination is combination 4, 2, because r now will increase by 1, so it will become 2. A to the power of 4 minus 2, b to the power of 2. Now plus r will increase one more time, so it will become 4, 3, a to the power of 4 minus 3, b to the power of 3 to the power of r, and the last one is going to be combination n is 4, r is 4 this time, a to the power of 4 minus 4, and b to the power of r, which is 4. Okay, now let's evaluate this. Combination 4, 0. Combination anything 0 is equal to 1 times a to the power of 4 minus 0 is a to the power of 4 times b to the power of 0. Anything to the power of 0 is equal to 1. So that's the first term. Plus Combination for 1. Combination for 1, and it's combination for 1 or anything 1 is equal to itself. So it's 4. A times A to the power of 3 times B to the power of 1 plus combination for 2. Combination for 2 is permutation for 2 over 2 factorial. Permutation for 2. Okay, let's do it here. So combination for 2 is 4 permutation 2 over 2 factorial. Now 4 permutation 2 is 4 times 3 over 2 factorial, which is 2. Cancel the 2 with the 4, we get 2, and 2 times 3, we get 6. So this is going to be 6. So it is 6. A to the power of 2 and B to the power of 2 plus combination for 3. This is right here. Combination for 3 is the same as combination for 1 using the reduction formula, because 4 minus 3 is equal to 1. And combination for 1, we've just established that it was equal to 4. We wrote it here before, so it's 4ab cubed plus combination for 4 is the same as combination for 0, which is 1 times a to the power of 0, 4 minus 4, which is 1. Anything to the power of 0 is 1, times b to the power of 4. So in simple words, we can say that the answer is 1 times a to the power of 4 times 1 is a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. Now you might notice that this is the same answer that we got here. A to the power of 4, 4a cubed b, 6a squared b squared, 4ab cubed b to the power of 4. We got the same answer right at the end, and this answer is using the binomial theory. Okay, so I hope this one's clear. Let's do the other one. So let's do B. Okay, so for question B, we have another expansion to do. Just erase this. Okay, for question B, we have 2x minus 3y all to the power of 5. Okay, let's start. According to the binomial theory, this is going to be, again, summation. So this is equals to summation r equals to 0, and n this time is going to be 5 times we combination of combination. N is 5, and r, as we just agreed, r is not going to be only one value. It will be an array of values starting from 0 up to 5. So we'll just write r for the beginning. So r times a. This a does not mean only always the letter a. It means this first term in the binomial. And our a is not a. Our a here is what? It's 2x. So what we write here is 2x to the power of 5 minus r times b, the other one here, which is b. B is actually the second term in the binomial with this sign. So b is actually all of this. So this is A and this is B. So B is going to be negative 3y to the power of r. Okay, now let's attempt to solve this one. So it's equal to, at the beginning we will assume that r is 0. So it's going to be combination 5, 0 times 2x to the power of 5 minus 0, which is n minus r, times b, which is minus 3y to the power of 0, plus combination 5, 1 times 2x to the power of 5 minus 1 times negative 3y to the power of 1, plus combination 5, 2. Remember that every time we just increase r by 1. So 5, 2. 2x to the power of 5 minus 2 times negative 3y to the power of 2, plus combination 5, 3. 2x to the power of 5 minus 3 times minus 3y to the power of 3, plus combination 5, 4. 2x to the power of 5 minus 4 times minus 3y to the power of 4. We still have one more term to go, plus combination 5, 5. 2x to the power of 5 minus 5 and minus r, and minus 3y to the power of r. Okay, so this is going to be the whole expansion, and now let's try to solve it. So for the first term here, combination 5, 0 is 1, and 1, so we write 1. 2x to the power of 5 minus 0. So it's going to be 2x to the power of 5. Negative 3y to the power of 0. Anything to the power of 0 is equal to 1. So that's the first term, plus the second term, combination 5, 1 is 5. 2x to the power of 4. So times 2x to the power of 4 times negative 3y to the power of 1. So it's times negative 3y. Then plus combination 5, 2. Okay, let's do this aside. Combination 5, 2. This is 5 permutation 2 over 2 factorial, which is 5 times 4 over 2 factorial, which is 2. We cancel the 2 with the 4, we get 2. And 5 times 2 is equal to 10. So this is going to be equal to 10. Combination 5, 2 is 10. 2x to the power of 3. 2x to the power of 3 times negative 3y to the power of 2. Negative 3y to the power of 2. Plus combination 5, 3. Combination 5, 3 is actually equal to combination 5, 2. Why? Because of the reduction formula. Combination 5, 3 equals combination 5, and here 5 minus 3. 5 minus 3. And 5 minus 3 is going to be 2. So they're equal to each other. So combination 5, 3, you don't have to solve it again. You just write 10 because it's the same as this one. Times 2x to the power of 2 times minus 3y to the power of 3 plus combination 5, 4 is the same as combination 5, 1. And the answer is going to be 5. So it is 5 times 2x to the power of 1 times negative 3y to the power of 4. And eventually, this is going to be plus combination 5, 5 is going to be 1. We don't write it. 5 minus 5 is 0. 2x to the power of 0 is 1. So we eventually write negative 3y to the power of 5. Okay, this answer is still not the final answer. We still need to simplify it. So let's see, how do we simplify it? I'm going to erase the top part here. I'm going to erase the top part. We will write it again later, and we will continue the question here on the top of the page. So let's see. Okay, so what do we get now? 2x to the power of 5. We raise 2 to the power of 5. So 2 to the power of 5 is equal to 32. And we raise also x to the power of 5, so we get x to the power of 5. Plus. Or actually, it's not a plus. Actually, it's going to be a minus. Let's see why. Now look at this, guys. This is positive, and here we have a negative 3. The negative 3y here. So the negative is multiplied by the positive. So the second term should be negative. And then 5 times 2 to the power of 4, which is 16, times x to the power of 4, which is x to the power of 4, times 3y. And the negative is just right there. Then plus. In the third term, this is negative. So negative squared becomes positive. So here, this term is going to be positive because the answer here is positive. Negative squared is positive, times positive is positive. 10 times 2 cubed, which is 8, x cubed, times 3 squared, which is 9, y squared. This is going to be the third term. Plus. Or maybe this is not going to be a plus. This is going to be a minus. Let's see why. Look at this, guys. Now, here, this is negative 3, this is negative cubed. And if it is negative cubed, then the answer should be what? The answer should be plus. So this is negative 3 cubed. Just write it clearly. This here is negative 3 cubed. And if it's negative cubed, the answer should be minus. Minus times plus is minus. Sorry if I said plus earlier. So it's minus 10 times 2 squared, which is 4x squared, times 3 cubed, which is 27y cubed. So this is going to be now the fourth term. So we still have 2 more terms to go. So the fifth term. So the fifth term is right here. So it will be plus, because a negative to the power of 4 is positive. So we have 5 times 2x to the power of 1 is 2x, times 3 to the power of 4 is 81, y to the power of 4. The last one is going to be negative because it's negative to the power of 5, which is minus. 3 to the power of 5 is 243, and we get next to it y to the power of 5. We can just simplify our answer eventually. So we get 32x to the power of 5 minus 5 times 16, we get 80, and 80 times 3 is 240. So 240 x to the power of 4 y plus 9 times 8 we get 72, and 72 times 10 is 720. So 720 x cubed y squared minus 27 times 4 we get 108. 108 times 10 is 1080. X squared y cubed plus 5 times 2 is 10, and 10 times 81 is 810. X y to the power 4, and eventually minus 243 y to the power 5. 243 y to the power 5. So this is going to be the expansion of this binomial. So when we expand this binomial, this is the answer. Okay. Now again, this is not going to be the way that the questions will be in the ministry for sure, because expansion takes a long time and we don't usually need the full expansion. Now, what they will be asking you about in the ministry is to find only one term. Now, notice with me that here, this answer is actually composed of 6 terms. We have 6 terms here. This is called T1, the first term, and this is called T2. Here this is T3, here this is T4, and here this is T5, and here this is T6. And in the ministry, most likely they will be asking you to find only one term. So they will ask you to find the 4th term in this expansion, or maybe the 2nd term in this expansion, or maybe the 6th term in this expansion. So how do we find a certain term without having to expand the whole binomial? We will see this inshallah in the coming slides. Okay. Now it's important to notice the following. Now look at this, guys. Here we will have some important notes that I want you always to pay attention to. So these are important notes. And these important notes are, first of all, for this expansion, a plus b to the power of n. So any 2 terms like x plus y to the power of 5, or a plus b to the power of 7, like for example this one, like a plus b to the power of 4, or like the previous ones, a plus b to the power of 2, a plus b to the power of 3, a plus b to the power of 4. So these notes, the following notes, are going to be first of all for this one, a plus b to the power of 1. What are these notes? The first note is about the power of a. The power of a decreases from n to 0. What do we mean by that? Let's go back a little bit. Look, this is here n is 4. Look at the power of a. It was 4, and then it became 3, and then it became 2, and then it became 1, and then here there is no a, which means that a has a power of 0. So the power of a decreases until it becomes 0, from n to 0. The second note that we can notice is that the power of b increases from 0 to n. Do you see here? So the power of b, look at the power of b. B here has a power of 0. There's no B. But B here has a power of 1. B has a power of 2. B has a power of 3. And B has a power of 4, which is the same as n. So the power of B increases from 0 to n. The third note is that the coefficients are symmetrical. They are symmetrical. What do we mean by that? What does this statement say? Okay, let's see. So the coefficients are symmetrical means the following. If you see here in this expansion, the coefficient of the first term was 1, and the coefficient of the last term was 1. The coefficient of the second term was 4, and the coefficient of the last term was 4. The coefficient of the middle term is 6. So it's like here, if we divide this binomial from here, and we look at it from the left and from the right, we will notice that the coefficients are the same order, 4, 1, and here 4, 1. Same thing here, if we divide this binomial from the middle, and look at the coefficients from this side and from this side, it is 1, 3, and here it is 3, 1. So they are symmetrical. If we divide this from the middle, we will notice that the coefficient here is 1 and the coefficient here is 1. This is actually a fact that happens always whenever you have a plus b to the power of n. The coefficients are going to be symmetrical. This is not the case if you already have coefficients like 2 and 3. You see here, the final answer, the coefficients are not symmetrical. We have completely different answers. So the coefficients here are not symmetrical. The coefficients will be symmetrical if it's a plus b to the power of n. Okay? One more thing. The sum of powers in each term is n. Okay, let's look at this example. Look at the sum of the powers. What is the sum of the powers? The power here is 3 and the power here is 1. If we add them together, we will get 4. What is the sum of the powers here? 2 and 2. If we add them together, we get 4. What is the sum of the powers here? 3 and 1. If we add them together, we get 4. In this term, it is 4. In this term, it is 4. So we notice that the sum of the powers is equal to 4, which is n. Is it a coincidence? Let's check here. The power here is 3. What is the sum of the powers here? It is 2 and 1, which is 3. What is the sum of the powers here? It is 1 and 2, which is also 3. And here, the sum of the powers is 3. So 3, 3, 3, 3, which is the same as the power, which is 3. So this is a fact. It happens all the time. The sum of the powers in each term is n. This does not have to happen with the expansions like this. Yes, it is true for this expansion, but for some other expansions, this will not be true. So we say it is true always when with a plus b to the power of n. Okay. So these are important notes regarding a plus b to the power of n. And please pay attention to these notes because these notes usually come as true or false or fill in the blanks. So you need to memorize these notes. It saves you a lot of time instead of thinking inside the exam whether it is true or false. Just memorize it. It's always like that. Okay. There is also some important notes, but these important notes, let's move on. So these important notes are for any binomial. So it doesn't have to be a plus b to the power of n. By the way, guys, here it is for a plus b to the power of n, or x plus y to the power of n, or c plus d to the power of n. The most important thing is that you don't have coefficients. There are no numbers, and it's plus or minus, doesn't matter. It can be also for x minus y to the power of n. So these notes apply for any expression or any binomial that looks like this. But the coming notes are for any binomial, whether it looks like this, whether it looks like these, or even if it has numbers like this one, even if it has coefficients like this one. So it applies all the time. Let's see this one. So these are some important notes for any binomial. What are these notes? First thing, the number of terms is always equals to n plus 1. Okay, what do we mean by that? Look at the power. What was the power here? Maybe it's here. Okay, what's the power here? The power here is 4, right? How many terms did we get? We got this term, number 1. We got this term, number 2. This term, number 3, 4, and 5. So how many terms did we get? We got 5 terms with a power of 4. If the power is 3, how many terms did we get? 1, 2, 3, 4. We got 4 terms, and the power was 3. If the power was 2, how many terms did we get? 1, 2, 3. We got 3 terms, and the power was 2. So the number of terms, even here, look, what was the power here? It was 5, and we got 6 terms. So the point is, the number of terms always is the power plus 1. Or let's replace this by a more accurate one. So the number of terms is always equal to the power plus 1. The power plus 1. So if you're trying to expand something like this to the power of 20, you have to know that you will get 21 terms. It's going to be a long answer. So if you're expanding power 20, you'll get 21 terms, because the number of terms is always the same as the number of powers, power plus 1. Okay? That's the first important note that we need to know. The second important note that we need to know is that the sum of all the coefficients in the expansion is equal to the coefficient of A, the first term, plus the coefficient of B, all to the power of n. So what do we mean by this one? Let's see. Now look at this, guys. It's okay if you have a calculator next to you now. Look at this. What are the coefficients in this expansion? Let's add them together. There are 32. There is minus 240. Minus 240. There is positive 720. Positive 720. There is minus 1080. There is positive 810. There is negative 243. Please put these with their signs into the calculator. Just add them with their signs. how much will the answer be? You will notice that the answer is going to be equals to -1. I can actually expect -1 from the beginning. I can anticipate -1 from the beginning without doing this. How? I will look at the coefficient of the first term. What is the coefficient of the first term? In my case, it's 2. And I will add with it the coefficient of the second term. What's the coefficient of the second term? It is -3. And I will raise them to the power of 5. What is 2 plus -3? The answer is -1. To the power of 5, it is -1. So we will get the same answer whether we follow this method or we do this method. This is true for all binomials. Let's see another one. Maybe this one, I hope it's still clear. The coefficients here are 1 and 4, positive, and 6, and 4, and 1. So if you add them, you'll get 16. Let's check it from here. If we take the coefficient of the first term, which is 1, plus the coefficient of the second term, which is 1, and we give it a power 4, it will be 2 to the power of 4, and 2 to the power of 4 is equal to 16 as well. So we get the same answer whether it's from here or from here. So the point is, the sum of all the coefficients in the expansion is always equal to the coefficient of the first term plus the coefficient of the second term to the power of n. Okay. Another important note, number 3, is regarding the middle terms. Middle term or terms. Look at this, guys. In this expansion, here, in this expansion, the power was 2. And we got one middle term. If this is T1, this is T2, this is T3, the middle term is T2. When the power was 3, I had 4 terms, T1, T2, T3, T4, and actually I had 2 middle terms. There were T2 and T3. T2 and the next one, which is T3. When the power was 4, I had 5 terms, T1 and T2 and T3 and T4 and T5, and the middle term was T3. So how do we get the middle term? And when do we have only one term? And when do we have 2 middle terms? So this is an important thing. Okay. The middle term or terms. If the power is even, you will get one middle term only. One middle term only. And the order of this middle term, which term it will be? It will be T of power divided by 2 plus 1. How is that? Okay, for example, in this example, what was the power? The power is 2. So the middle term is going to be 2 of order 2 power divided by 2 plus 1. What is 2 plus divided by 2? It is 1. 1 plus 1 is equal to 2. So T2 is going to be the middle term. Here, T2 is the middle term. If the power is 4, then take T4 divided by 2 plus 1. 4 divided by 2 is 2. 2 plus 1 is 3. So it's going to be T3. So the middle term is T3. So whenever the power is even, we will have only one middle term. And how do we get the order of that middle term? We divide the power by 2 and we add 1. Okay. If the power is odd, then how do we get? We will not get one middle term. We will get 2 middle terms. two middle terms. And the order of the first will be t power plus 1 first, and then we divide by 2. It's similar to this rule, but in this rule we divide by 2 first, and then we add 1. Here we add 1 first, and then we divide by 2. This is the first one. And the second one, the second is the next. What do we mean by that? Look at this, guys. So here, for example, the power is odd. So if the power is odd, we're expecting two middle terms. The first term will be t, take the power, add 1, and divide by 2. This is going to be 6 divided by 2, which is t3. So the first middle term is t3. And the next middle term is the second middle term. So the middle terms are going to be t3 and t4. So t3 and t4 are the middle terms. Okay? I hope that this is clear. These notes, all of these notes are important. These will be used in some examples and exercises. We will be using these two notes to determine the middle term. This one is usually in fill-in-the-blank questions, or in multiple choices, or in true or false questions. This is also in multiple choice and true or false questions. So these notes are very important. Beside these notes, please write them down. Make sure that you write them down and you understand them well. Okay. And before we end the class of today, there are two rules that I need you to memorize, so that next class, when we solve questions, I want you to be better prepared. Okay. The first rule, this is the rule that we usually use in the ministry. I told you before that the full expansion is not used in the ministry a lot, but they usually use the general term formula. What does the general term formula says? It says t r plus 1 equals combination n r a to the power of n minus r b to the power of r. It's the same as what we have inside the expansion. And we use this rule usually to find any specific term that we want. For example, if we want to find the fifth term, or we want to find the fourth term, or the third term, things like that, then we use this formula. There is another formula that is important. It's the ratio of two consecutive terms. It's like this: tr plus 1 over tr equals n minus r plus 1 over r, I think you have seen this rule before, times b over a. Okay, this rule looks like a previous rule that we did before, but not with tr plus 1 over tr. It was a rule like this: cr minus 1 equals n minus r plus 1 over r. And in that day, I told you that this r is always the bigger r of the two. So this is the bigger r, so here we use the bigger r. And we did this in combination. Here, this r is not actually the bigger r, it is actually the smaller r. So this one and this one, this is the smaller r. And we add to it b over a. b means the second term, and a means the first term. And just to avoid any confusion, guys, the main rule that you need to memorize for sure is this one. I call it the one rule. Any binomial question, any question that can be solved using the binomial theorem in your ministry exam will follow one rule. Which rule is that? This rule. So you don't need to memorize a lot of rules. This is one rule. This is the rule that we'll always use to solve any question in the ministry, except one case only. When you see that the question contains a ratio of two consecutive terms, you'll use the second rule, which is this one. So please try to avoid any confusion. This lesson is not hard. It's just one basic idea. It's this basic idea. I will just follow it all the time. This is the one rule that we will do all the time, and we do this whenever the question is about ratio. So that's it. That's all for today. Before I leave you, I would love that you have some practice with an exercise. So here, I would love if you can solve this question. I want you to expand a plus b. Let's not do it as a plus b. Let's say it is x plus y x plus y to the power of 5, and expand also 2x minus y squared to the power of 4. I'll be more than glad if you can do these two and practice with them. Memorize the formula that I gave you in the last slide before you start with me on the next lesson. And in the next lesson, we will see some ministry questions of the binomial theory and how do we solve these questions using the one rule only that we have, which is the rule of the general term. I wish you all the best. Stay home, stay safe, study hard, and I'll see you inshallah in the next video.